spot.
Oh, for a long time, like about 100 days.
Yeah, Red Sox.
What the hell? You suck. You just failed the class. Don't even show up. You suck. Anyway. But they're in game buttons. He's just...
I know. He knows your buttons. Keep pushing them.
Yeah. I'll make up a special test for you, Don. I got you.
How is Kansas City doing?
Pretty badly. Well, not poorly, but they're like middle of the pack. They're basically eliminated.
Didn't they win the, what is it, last year?
Yep, they were winners last year.
Oh.
They won the whole thing. And they didn't even have that good of a record. I mean, they had a winning record, but I think they had 86 wins, which just barely is above 500. And they won the whole thing because they got hot at the right time. That happens. The Orioles just can't score runs. I mean, it's terrible, especially based on a team that's predicated on scoring runs. So, I don't know. They're going to limp their way in. And if they take the wild card, they're going to get eliminated, I think, the first game. I hope not, but they just don't look good against teams that are over 500.
Maybe they're all, maybe the fear of getting shot on your way to work is really
That does kind of play into a factor, except they're on the road right now. So.
Well, nevertheless, if it does, and I mean it seriously, but because if you get there and you're going to work and you're nervous on your way, it can affect practice and everything.
Sure.
You know, and they've had a lot of violence right outside of
Oh, yeah. Oh, yeah. I know.
You see the game with the stadium and ESPN highlights last year?
Yeah, I was actually.
Oh, yeah.
I was at the game when the riots went down. So the police were outside there, and it was a storm. I was in the epicenter of that whole thing.
Wow.
I saw it. I saw it all. I saw like cars backing up, like people jumping on top of cars, people knocking over the hot dog stands, people stealing condiments and squirting them all over other people. It was one of the. It was probably the ugliest sight of humanity that I've ever seen in my life. It was horrific.
We didn't go into Baltimore for.
Yeah, I mean, I don't blame you.
We still don't go in there.
Yeah. I mean,
Used to go down for like the circus, things like that.
yeah.
Don't go in there for anything.
Yeah.
During that time, the riots time, I had a relative that was in the hospital at that time at Johns Hopkins. So we were going there, and there were so many armored soldiers just kind of hanging out in that area.
Wow.
So many.
Bad.
So many.
It really was.
Oh yeah.
Like people, I don't think people really understand the gravity and the levity of what happened. I mean, it was historical. It really was. I mean,
It's the reason their mayor is not going up for election.
yeah. Well, I mean, anyway.
Yeah.
Yeah, they locked us in the stadium too. After I think it went into extra innings. I remember they actually locked us in. They were like, "You're not allowed to leave."
But I thought you said it was going on inside the stadium as well.
Oh no. I was outside the
outside.
stadium when it all happened. So
Okay.
yeah, I was having a few beers somewhere else, and it all went there.
And then you got back in the stadium and
Yep.
they kept you in there.
And they would not let people out after, I think it was the 10th inning or something like that. And they literally locked us in there for about 2 days. And people were having a fit. Yeah, it was, I mean, I can't remember the last time that in any city that people have been locked in somewhere and weren't allowed out. Because they were that fearful of the safety and the well-being of people.
It was probably the smart move.
I agree. Yeah, and you know people.
They're going to complain anytime
Oh, yeah, they're
they're
gonna-
told no.
Yeah, they're gonna complain like if peanuts are like, $3.25 instead of $3, so, yeah. I completely agree with you. Once you take away someone's ability to make a choice, then people get restless, really. But yeah, it's fun stuff.
Even though I wouldn't have known that probably the best choice, I would have complained. That's.
Yeah, well.
You know, it's anything, anybody does, especially for the $3.25 peanuts.
Yeah. And the bad thing is they stopped serving beer at the top of the 7th, so we couldn't even get a few more beers.
Right.
It's frustrating. And my flask was out that I brought in, so.
Yeah, I haven't been to the stadium since you weren't able to bring a cooler.
Yeah, that's frustrating. You can bring in.
You bring in a clear plastic bag.
Right, and you can bring in.
It's like, really? You're going to put ice in that?
Yeah, exactly. You can bring in bottles that are plastic and they're not broken. So, and then they sell them outside the stadium for like $2 a pop, which I guess is better than paying like 5 something to sell it. It's still, I mean, I just want to bring in some water or something like that. Why do I have to spend $1 or $2?
You go in with a cooler with the soda on top and buried in the bottom with your beer that you're not supposed to bring.
Yeah,
in.
right, yeah. I just bring a flask in. Yeah. I have a plastic flask. It's all good. Tuck it in.
Water bottles full of vodka.
Yeah, that'll work. See, what's scary is that we're a third of the way through the semester after today. Because it's been 5 weeks. That's messed up. I didn't hear a word you said. It's probably better. You know how easy it is to put an F in for your grade? It's just as easy as to put an A, B, or C in there for you, you know? It's just as easy. In fact, it might be more enjoyable for me.
How many Fs have you given out since you started teaching?
Oh, God. I hate to say it, but probably like 1,000. Because I've been teaching for like 13 years, so, you know. You gotta figure, like, I mean, every class, I've always got, like, you know, a person or two that just never even shows up. That's on the roster, and they never withdraw. So, and you gotta figure, I taught 5 courses a semester. I usually teach 2 in the summer. So that's 12 courses a year. Generally, on average, I'll have 20 people in a class, sometimes more, sometimes less. So 20 12 is 240 times whatever it is, times 12 years, 13 years of teaching. So we're getting to 36,000 students or something like that, or 36,000 unique grades that I've given out. So out of those, you know, I mean, you gotta have some failures in there. Thousands. Not that I like to, but you know, have to. Well, that's kind of depressing now that I think of it. And I think of all the time that I spent grading papers.
After the first exam, I think this class would be fun.
Where's everybody? Oh, we're now. Good enough reading. It's Wednesday at 3:15. Good enough reason. Is anybody taking linear algebra? Just curious. Okay. Oh,
I'm kind of planning on doing it next semester.
okay. Some of the stuff that you guys use in this class is used in linear algebra proofs and stuff.
Do you teach linear algebra?
There's one person that has a stranglehold on it, so unless that person dies or quits, very soon. So one of the two is going to have to happen. So I'd like to. I'd like to have $1 million too. Ain't going to happen. Oh well. Okay guys, so I think what we need to do today is we need to finish up our proofs, and I think we stopped with just barely getting into rationals. I think last time we went to proved, or not even proved, but shown a couple things are rational. So today what we're going to do is we're going to do proofs involving rational numbers, and then we're also going to do proofs involving divisibility. Okay? And then I know a couple of you guys had some questions about the assignment number 4, so make sure you guys ask me before you leave to show a hint for, I think there's one of the problems with like -1 to the n, if n is odd, to show that that's equal to -1. So make sure you guys remind me and I'll show you a hint to that one. If there's anything else you guys might need a hint to, I'll be happy to show you. Okay, so let's go ahead and do a couple direct proofs involving these rational numbers, okay? They're not too difficult. Most of them follow the same pattern, okay? So these two that we have for all x, y, and z irrational. I want to prove that 2x squared minus y plus 2z is also rational. Okay, so let's go ahead and try to think of like the steps that we need for a direct proof. Okay, so I think the first thing for any direct proof that we talked about, guys, was didn't we need to define the variables and use the definitions of rationality, divisibility, even, odd at that point. Okay, so let's start by saying, let's let x, y, and z be elements of the rational numbers. Okay? And we can say, or we don't have to say, but such that x, y, and z are arbitrary or particular. Okay, so x, y, z, arbitrary but particular. And then we'd have to use the definition of rational to be able to work with this. Okay? So by definition of rational, okay, we have to be able to say something about x, something about y, and something about z. So, what could we say about x if x is a rational number? In other words, how do we define a rational number?
X is equal to a over b, where
Sure.
b cannot be 0.
Perfect. So we can say x is equal to the quotient of a and b, where b is non-zero. Okay, good. And then what can we say about y then?
C and d.
C over d, right? We don't want to use the same variables because that would imply that x and y would be equal. So it would be c divided by d, where d is non-zero, right? And then for z, we could just say e over f, where f is non-zero. Okay? And we have to do one more thing to be able to truly make sure that we've used the definition of rational here. And we don't have to say that there's no common factors between that. So what's the other thing we should probably define at this point?
What? X, y, z cannot be 0?
Not necessarily. They could be 0, because we could have 0 over 5,
Oh,
or
yeah.
0 over 22. So that's okay. And
The A, B, C, and D, and the E, and F all have to be rational.
not rational, but
Integers.
right. A, B, C, D, E, F have to be integers, right, guys? Because remember, the definition of rational is integer divided by integer. Nice, guys. All right. So, A, B, C, D, E, and F are all elements of the integers. Okay. All right. So, anytime we start a proof, we have to define the variables, okay? Just like a computer program, okay? It's almost like why this course is made for computer science majors, okay? Second thing we have to do is all the algebra junk, okay? So this is where we have to go back and do all that stuff. What's usually the first step that we do with the direct proof? Substitution, when we start doing the algebra stuff. And that's exactly what we're going to do. So we're going to say by substitution, what are we substituting into, guys?
In x, y, z.
Into x, y, z, in particular, like what statement?
A, b, c, d, e, f.
Into 2x squared minus 1.
Oh, yeah.
Right, into 2x squared minus y plus 2z. Okay, good. So that means by substitution, our 2x squared minus y plus 2z is going to become 2 times the quantity of a over b squared minus c over d plus twice e over f. Okay, so that's our substitution step. Okay, I don't think anyone has any problem with that, right, guys? That's basic. Okay. All right. Now, what are we trying to show with all this garbage?
Yeah,
Or,
rational.
sorry, all of these statements. What do we ultimately have to show that this is equal to?
Rational. They have
A
like
rational number, right, guys? So in other words, like maybe like m over n or something like that. Okay. So how do you guys think we might be able to proceed with this? Like, what might be the most obvious thing to do?
first expand it and do the algebra.
Yeah, let's go ahead and maybe expand this animal right here. So at least we just have like some fraction to work with. So just by multiplication. Okay. So multiplication, this is going to become 2a squared over b squared, right, guys? So all I'm doing is I'm just moving the 2 in the numerator, squaring the a, squaring the b. Okay. Minus c over d plus 2e divided by f. Okay. All right. Now, like we said, we want this to become like m over n or something like that, right, guys?
Yep.
So, Any ideas to perhaps what we might need to do at this point to get it into one fraction done?
Multiply the opposites.
On the right track, not opposites, but I think you're thinking the right thing. You might not just be saying it
The
correctly.
denominator common.
Common denominator, right? Yeah, I think you're on the right track, right? Yeah, eventually you just need to basically multiply what's missing there, okay? You had it in your head, and you were explaining the steps correctly. Yeah, we need a common denominator. So, guys, what is the least common denominator for all three of those
B
terms?
squared df.
Yeah, just mash them all together, right, guys? So the LCD for this would be b squared df. Okay? So now what we're going to do is we're going to rewrite everything using the least common denominator. Okay? So our LCD, I'm just going to rewrite each of the denominators with b squared df. And Donnie, I think this is what you were talking about, where you have to cross multiply, if you would, okay? So,
Can't we just skip that step and just write it as the,
Bis-
just all over
Oh,
one?
sure,
just one,
yeah.
just combine it
I
to
just
the
want to make
step?
sure that everyone understands like how to get to this point, okay? So, if you just want to skip this and just want to make it like one big mega fraction, you can. I have no problem with that. Okay? Now, what I'm interested in though, guys, is making sure you know how to write the equivalent fractions, okay? Could somebody tell me what the numerator of the first fraction is going to look like once we have a common denominator?
2a squared df.
Okay, so 2a squared times d times f. Okay. Where did the df come from? Well, guys, take a look at this. The LCD was b squared df. Didn't we already have b squared? So all we really need to go from b squared to b squared df is this df. So basically what you're saying is, whenever you need to multiply to go from the previous denominator to the least common denominator, that's what you multiply the top by. Okay, that's like your cross multiplication, which you were thinking of. Okay. What about for the second fraction? We're going to have the c up there, that comes down. But what other two factors are going to be multiplied in the numerator?
b squared f.
B squared, because to go from d to b squared df, there's no b squared and there's no f. Okay. And then finally, guys, for the last one, since we have the f, we copy down our 2e. And what two factors are going to get multiplied in the numerator this time?
b squared d.
B squared d. Nice. Okay. Is that good with everybody, guys? Any questions about that? Okay. All right, Andre, I think you said let's just make it into one mega fraction, and you could have done that. I just wanted to make sure it was perfectly clear going from one step to the next. So that's our next part. We're just going to make this into a huge mega fraction. So this is going to be equal to all that crap, 2a squared df minus cb squared f plus 2eb squared d. All over the common denominator of b squared d. Okay? And guys, that's just literally addition. Okay? All we did right there was we just combined it, we just made it into one big fraction. So this is addition. And I think we're done, right guys? Because what's the last thing we have to do to show that this is rational?
You have to call define b squared df as n and the numerator as m. That's
Yeah.
it.
And guys, what's that step called where you can combine everything and just make it
Definition
into an
by
integer?
definition.
Closure, right
Closure,
guys?
closure.
Right. Guys, remember, addition, multiplication, and subtraction are all closed under integer operations. Okay? All of these are integers. So their product is an integer. The difference of two integers is an integer. The sum of two integers is an integer. This is a product. So we can just call this m over n, right guys? Okay. So this is just by closure. There's one other thing, or maybe a couple other things we should define. So what's one other thing we should probably state about this? Yeah, m and n have to be integers. Good job. So m and n have to be integers. M, comma, n in z. And then, although it doesn't really matter that much, all right, What's one more thing that we know?
N is not equals to
Yeah,
0.
n should be non-zero, because then it wouldn't be rational, right guys? If you divide by 0, then it's just not a real number anymore. It approaches either positive or negative infinity. And we don't want to deal with limits. That's so Calc 1. Okay.
So
Right.
wouldn't the n not being 0 already be implied because it says b, d, and f?
Correct, right, because we already defined B, D, and F to be non-zero, so we don't necessarily have to state it again, but I don't know how picky your next teacher is going to be, so I always go for more detailed
But
ones.
0 is an integer. It's 0
It is, but you can't divide by 0, right?
Yeah.
That's not rational. That approaches either positive or
Negative infinity, yeah.
right? So that's why we have to state that at some point. Okay. All right, guys. Guys, isn't it clear that this form right here, 2x squared minus y plus 2z, is equal to m over n, which is rational by the definition of rational? We're done. Okay? So for step 3, we would say that thus 2x squared minus y plus 2z is equal to m over n, which is rational by the definition of rational. Definition of rational. And we're done. So is this marker. So let me ask you guys, any questions about being able to prove one of these types of rational statements by utilizing our rules and all that stuff? Okay, not too difficult, right guys? It's basically just what we did the other day, except now we just have a little bit different algebra stuff. Alright, so why don't you guys go ahead and try to do letter R number 2, which is basically the same problem, it's actually a little bit easier, okay? So I'll give you guys about 6-7 minutes to see if you guys can work that through. We'll go through the answer together and then we'll talk about divisibility. Sounds like fun, right? Yeah, go ahead. Oh yeah, that would be helpful, wouldn't it? Sorry, Gino. Actually, I will give it to you if I have one. There you go. Does anybody else need one of the packets? Sure, no problem. And of course, guys, if you need help, let me know so I can help you guys out. So what I did was I started the proof by defining the singular variable we need. We just need x. Okay? And I defined that to be rational. By definition, rational, x is equal to a over b, or whatever two variables you want to, as long as you're not using x again. Okay? I said that b was non-zero, and I also said that a and b were integer values. Okay? So that'd probably be the way you want to start off. If you do that, I can at least give you 2 points out of 10 for this. Okay. Now, we're substituting back into, what was it, 7 minus x cubed? Or
5x cubed.
Oh, 7 minus 5x cubed. Sorry about that. So, by substitution, 7 minus 5x cubed is going to become 7 minus 5 times the quantity of a over b cubed. Okay. So that's not a big deal, right, guys? I bet you everyone was able to expand that, right? You just said that that's going to be 5a cubed over b cubed, okay? And what you might have also wanted to do was maybe do like the 7 over 1 minus 5a cubed over b cubed, okay? And that's just by multiplication. Somebody tell me, guys, what is the least common denominator between those two fractions?
B cubed.
B cubed, right? Because it's the only denominator, right? That's easy, okay? So what we're going to do is we're going to rewrite both of those using the LCD, okay? And I'm just going to go ahead and write it as one big old fraction so we can just skip that step, okay? Could somebody tell me what their numerator looked like when they combined it into one fraction besides m over n? Go ahead, Ryan.
7b cubed minus 5a cubed.
Sounds good to me. 7b cubed minus 5a cubed. Okay. Does everybody understand how Ryan did that? Notice that the 1, to get to a common denominator of b cubed, you needed to multiply by b cubed. There was nothing in that denominator. Okay? So it's just like whatever you're missing, multiply the top line. Notice to go from b cubed to b cubed, you didn't need to do anything extra. So the first term stayed or the second term stayed the same. Okay? At this point, guys, what's the last algebraic step we need? Closure. We always need closure, right? All right, so it's like a Lifetime movie. We need closure. All right. We can say that that's m over n, c over d, beta over theta, whatever you want to do. We'll just use m over n. Okay, so by closure equals m over n, m comma n are integers. If we just wanted to be explicit about it, we could say n is non-zero. Okay? And clearly, just like the last example, is it not true, guys, that 7 minus 5x cubed equals m over n, which is rational by definition of rational? And we are done. Okay? So step 3, thus, 7 minus 5x cubed equals m divide n, which is rational by the very definition. Definition of rational. Okay. Generally, when an exam, I'll put something like this one. Okay. Because and I'll probably also put one that of the divisibility ones. Okay. The integer stuff, I mean, that's fundamental stuff. So these are probably like a little bit tougher. I don't think they're too difficult for you guys. But generally, what I do on the exams is the way I work the exams is like I probably have like maybe 5 direct proofs and then 2 of the other types of proofs that we're going to do at the end. Okay, so, and then I also have like some short answer stuff. So just kind of getting you guys to think about maybe in like about 3 weeks when we have an exam. Okay, guys, any questions I can answer about proofs with rationals? Okay, they're pretty much all the same. There's not much difference between them. Okay, divisibility is going to be the last topic that we talk about for assignment number 4. Okay, and you guys know what divisibility is. There's a lot of different ways to define divisibility. Okay. If you guys ever see this statement, okay, A divides B, okay, so this animal right here, okay, we're going to be seeing this a lot. That means that A divides B, okay, that means that B, if you divide it by A, it's going to give you an integer, okay. It means that you can write B as A times some sort of variable or integer value. It means that B is a multiple, and it also means that A is a factor of B, okay? Now, of all those that we want to list out, the one that's going to be most useful to us is this first definition right here, okay? When we start doing proofs, that's going to be the one that's going to help us the most, okay? The other ones are nice to know. They're not necessarily going to be essential for us to know, okay? So I always think of two different categories of knowledge. I always think nice to know and essential to know. Okay? This guy's essential. The other ones are nice to know. All right. Let's just look at two very, very basic examples where I ask you guys to show me that something's divisible. Okay? So I want to prove or disprove. Okay? So for the first one, we have -8 divides 48. Okay? Guys, we know that that's true. Let's take a look at a number of different ways that we could verify that. Okay? So somebody tell me, guys, why does -8 divide 48? There's a number of ways that you guys could explain that. So.
-1/6, multiply by -1/6 or something like that?
No, not quite. That's okay. Good try, Art. But
8 is multiple of 48?
yeah, because if we were to list out the multiples of 48, we could eventually run into -8. Okay, that's one of the reasons. Okay, I don't want to do that because I'm lazy. Okay, so I'll think of a different way to do it.
Because 48 divided by -8 is an integer.
Yeah, because if we divide those out, that's an integer, which would eventually give what you suggested. Okay, so one way to describe this is that because if you were to divide, we would say 48 divided by -8 is equal to -6, which is an integer. Okay? So, and that actually satisfies the third condition. Okay? If I wanted to use the first condition, couldn't I also say that 48 is equal to -8 times 6? Which is basically the same thing that you just said, James, okay? Except that I just went through and I used the first definition as well, okay? There's a number of ways that you could say it, okay? I think all three of the methods that we suggested are certainly viable, okay? So either way you guys want to do it, okay? So, does that make sense, guys? If it divides and gets an integer, that's going to be divisible. If you can try to find another number another integer that multiplies by what you're dividing into, it's also going to be divisible. Okay?
Because it's 8 times 6.
Oh yeah, that would be helpful if I actually knew my times tables, wouldn't it? So that's why I don't
Especially
teach.
as a teacher.
Yeah, well that was the irony of it. So that's why I don't teach basic math. Alright. Okay, sorry about that, guys. Regardless of my lack of knowledge of times tables. Any questions, guys, about that? That's fairly easy. Okay. What about this second one? And I know that we already did the one with rational. I'll make sure I fix that. All right. But does x plus 1 divide x squared minus 3x plus 2? There's a couple ways that we could be either show or disprove that. So, what were you thinking?
The synthetic deviation?
We could do long or synthetic division. I always just do long division because it's a little bit easier if there's a coefficient in front. Sure, we could do a long division with this. Okay, so let's do that. And then I'll show you guys another way that potentially might work. So just in case you guys forgot long division because you haven't had to suffer through it, although if you're taking Calc 2, you probably are suffering through remembering how to do that stuff. Remember to do long division, guys, you just look at the first terms. Okay, so I'm going to look at x, and I'm going to look at x squared. And don't I think to myself, guys, what multiplies by x to give me x squared? So guys, what does multiply by x to give me x squared? Just x. Good. So we have an x here. We distribute the x to these two. So x times x squared. X times 1 is x. And then don't we flip the signs around? Okay, so this would become a minus x squared and a minus x. I always tell my students in basic algebra, you know you're doing it correctly if the first terms negate. In other words, they go away. Okay? Because that's the whole purpose of division, is to figure out how many times each of those first two terms go into each other. Okay? Just like regular division, you bring the rest of the stuff down. So we would have -4x plus 2. And then don't we just do the whole thing over again, right guys? Okay? So, in this time, we're trying to figure out what multiplies by x to give us -4x. So guys, what multiplies by x to give us -4x?
-4.
-4. -4 times x, -4x. -4 times 1, -4. We flip the signs over. Notice that the x's cancel out, and that's exactly what we want to happen. And then we end up with 6, and nothing else to bring down. Okay? So, what is 6, guys?
The remainder.
The remainder, okay? Guys, if you have a remainder, what does that mean? Not divisible, right? That's the very definition of divisibility. Divisibility means that there's no remainder. So because we could just say, I think we would write this as what, plus 6 over x plus 1, okay? Because there's a remainder, or we could just say right here, it is not divisible since there is a remainder, okay? We don't even have to write the 6 over x plus 1 if we don't want to, but that's good enough, okay? So sure, we can always use long division. Long division always works, by the way, to prove or disprove divisibility. Okay? For this particular problem, what's another way that you guys could show that this does not work out? So, yeah, we could go ahead and we could factor this animal, right? So couldn't we go ahead and just factor this trinomial, and we could see that it's not a factor? Okay, so this is one method. If I was to ask you guys to factor that x squared minus 3x plus 2, what would this animal factor into, guys?
X minus 1, x minus 2.
And clearly it doesn't contain a factor of x plus 1, right guys? So that's a little bit faster way, okay? Now, what's the problem with relying on factoring all the time? Yeah, we have these things called prime polynomials, right? So that's why I said long division will always work, okay? Because you can always do long division. You can't always do polynomial factoring. Okay, go ahead.
So when you factor, if both of them didn't come out to x plus 1, is that, or does just one of them?
Just one of them needs to be, because all you need is one factor of x plus 1.
Okay.
But clearly there's not even one of them. Okay? So you just say neither factor is x plus 1, so not divisible. Alright, so that's fun. Yeah, how many of you guys, when you suffered through Calc 2, you remember those partial fraction decompositions and you had to do long division? Yeah. I'd rather saw off my arm with a rusty razor, but regardless. Guys, any questions I can answer about how you guys would show divisibility, whether it be with an integer or be with a polynomial? Okay, nice and easy, right guys? Alright, so next thing we need to do is we just need to do a few direct proofs, okay? So, one of the most important proofs with divisibility is the transitivity law, okay? I believe we took a look at transitivity when we had, and it was a while ago when we did the basic rules of inference. We had transitivity that way. Transitivity is one of the most fundamental rules of mathematics, and it happens a lot in math, okay? We actually have a divisibility transitivity rule, okay? Transitivity says that if A divides B and B divides C, then A must divide C as well, okay? Now think about this, guys. Think about numbers that we divide. Like let's say for instance, okay? Isn't it true that 2 divides 4? That's correct, right? Mm-hmm. I would also say that 4 divides 8. If that's true, then it must mean that 2 divides 8. Right? That's what transitivity says. And we know that that's true. There's not one person in this class that doesn't know that 2 divides 4, 4 divides 8, thus 2 divides 8. And that works every single time, okay? As long as the first 2 statements are true. Now, our job is to be able to prove that true for any integer set, such that it's true, okay? So, everybody understand what we're trying to show, guys? We're trying to show this rule is valid. So, let's go ahead and use our direct proof. Well, let's try to. Apparently not. Okay. So, first things first. Oh boy. It's like a ransom note. Bring 1 million cookies. Oh, it's gone. Real nice. All right. Let's try it again. There we go. Okay. So, we need 3 variables, right guys? That's so obvious. So, let's let A, B, and C be elements of what set, guys? With divisibility, are we working with rationals?
No, integers.
No, integers, right guys? So let's let A, B, and C be integers. Okay. I'll put in brackets. A, B, C, arbitrary but particular, yawn. And And there's one other thing that we have to say before we can start using definitions or substitutions. Okay, Don.
The denominators can equal 0.
That is true. We should say that A and B should be non-zero. We'll get to that in a moment, okay? So can you hold on to that and remind me? Because that is very important. Okay? So what's something else that we have to say? Don't we have a conditional statement, guys?
Oh,
Doesn't it
yes.
say if A divides B and B divides C, right? Don't we have to make that assumption? Anytime it says if, you have to assume that that's true. Didn't we do that the other day with perfect squares? We said if they're perfect squares, right? Then it plugged into that formula. So we're going to say such that A divides B and B divides C. Okay? So again, anytime you see a conditional statement, okay, then we have to make sure that the antecedent is stated somewhere in that proof. Okay? And Donnie, I'm going to say what you suggested as well. Also, A and B should be non-zero. Okay, so we'll just say comma A, comma B, non-zero.
Why A and B?
Oh, because those are the ones that are eventually going to be in the denominator, right? Because it says if A divides B, and 0 doesn't divide any number, ever. Okay? Now, so if they're on the right, if they're on the left-hand side of that divisibility bar, you should define them to be non-zero.
Why not C then?
What's that?
Why not C?
C will be
Oh,
new-
because C is what we're dividing into at some point.
C's never on the left side.
Oh.
Right, yeah. That's the only ones that are in the denominator. That's actually a really good question, and you guys explain that very nicely. Okay. All right. So, does that make sense to everybody as to why we have to assume that A divides B and B divides C? It's an if-then statement. Okay. So, because that's true, don't we now use the definition of divisibility? So, by definition of divisibility, we can say two things. We can say something about B, and we can say something about C. Okay, so by definition of divisibility, B is equal to something, and C is equal to something.
So B is a multiple of A, right?
That's correct, okay? And remember, didn't we say that we're going to use, in particular, this first rule right here, okay? So B can be written in the form of AC, but we don't want to use A because we've already defined A. So B could be equal to what, guys?
XC
X,
or MC?
XA.
X, sorry,
Okay.
X.
So B would be equal to X times A, because A is a factor of B.
B.
Okay, that's what divisibility means. Does that make sense to everybody, guys? If A divides B, that means some number times A is equal to B. Okay. What can we say then about C, since B divides C?
So you equal to YB.
So we could say that this is equal to Y times B. Because again, B is a factor, which means that if you have two integers that multiply, they should be equal to C. Okay. A couple other things we should say. Okay, so what should we say at this point now that we've introduced new variables? Yeah, we definitely have to say that X and Y are integers. Okay, so. We don't have to say they're non-zero. Everybody good with that, guys? Any questions? That's our definition part. Okay. Now we have to do the substitution part. The substitution part is going to be very, very easy. Okay, so this is one. Step two, by substitution, what are we trying to show, guys? We are trying to show that C contains a factor of what? A. Correct. Okay. So shouldn't we substitute maybe into C, if we could?
Yep.
So by substitution, C, which is equal to Y times B, is the same as C equals what?
Y times X over A.
Y.
That's XA.
Isn't it true that B is equal to XA? So we can just go ahead and substitute there. Okay? So, we're going to say that C equals YB becomes C equals Y times
X.
XA. We're just substituting back in for this YB right here. So this is XA. Is that clear to everybody, guys? We're just substituting, and that's only because we need to figure out, because remember, what we're ultimately trying to show is we're trying to show that A divides C. Okay? So we're picking on something that contains the C. Okay? Well, guys, aren't we almost done with this? Because what do we see clearly about C? It contains a factor of A, doesn't it? So could I not rewrite this? Okay? I could just use an associative and commutative property. Okay? I could just say, and we don't have to do this step, but I'm going to. By the associative property, isn't it true that C is going to be equal to quantity Yx times A? Okay? I mean, if you got a real ball buster for a teacher, they'd want you to show that, okay? And I don't mean that like, you know, in any sort of negative connotation. It does happen, okay? So they, yeah, maybe somebody like that. They might want to see that. Not saying that they would. But. All right. Guys, what do we know about Yx? It's an integer, right? Which means that Y times X could be written as M, N, P, whatever you want. By closure, right? So by closure, C is going to be equal to, you guys want to use M, why not? M, A. Or M is an integer. All right. Let me ask you guys a question. Is C divisible by A? Yeah, because it contains a factor of A. Right? In fact, isn't that the very definition of divisibility right there? The very definition of divisibility says that you have one integer is equal to some other integer times what you're trying to be divisible by. Okay? That is the core definition of divisibility. So the algebra in this was very, very little. It was a little bit sneaky though, right, because we didn't necessarily know what to substitute into. Okay? After we do another one, it might be obvious as to what to substitute into. But here's my suggestion, guys. We're not done with this. We're almost done. My suggestion, guys, is to always substitute into the right-hand side of what you're trying to show. Okay? So if you guys, when you guys go through your substitution step, always on the right-hand side of whatever it is that you're trying to prove. Okay? That makes it really easy. Okay. So let's go ahead and finish off this proof. Can't we say that by above, or thus, C is equal to MA and contains a factor of A? Which means it must be divisible by the very definition of divisibility. Okay, so thus, A divides C by definition of the worst word in the world, divisibility. It has 5 eyes in it. It's like my mother-in-law, she has 5 eyes, always watching me. Why are you drinking beer? It's because you're my mother-in-law, that's why. I wouldn't have to drink if you weren't. Regardless. Did you get that on film?
Yep.
Good.
I'll send her.
Yeah, send it to her. If only it was appropriate to show my ass, that would be awesome to show that to her as well. Regardless. Okay. Guys, any questions I can answer for you all about how we're going to approach this divisibility stuff? I know it's a little bit different than some of the other ones that we've seen, because the substitution isn't as obvious. Okay? Hopefully after we do another example, it'll be a little bit more obvious for you guys. Okay? So let's tackle another one. Okay. So, for all A, B, and C integers, again, if A divides B and A divides C, then A divides 10B minus 5C. Okay? This one's actually, I think, a little bit easier than the transitivity one that we've done. Alright. I bet you that we can start this problem out almost identically to the previous, except we're going to change one thing. Because I think we said if B divides C. So we're just going to have to change that second statement. So here's how we're going to start this out. Okay? Let's let A, B, and C be elements of the integers. Arbitrary, but particular. And remember, you don't have to write that, at least in my class, but somebody else might make you write it. And because it's a conditional statement, what's the other thing that we have to assume?
A divided B and A plus C.
Nice job. That A divides B and A divides C. Okay, such that A divides B and A divides C. Okay, so I'm feeling that. Once we've defined the variables, what's the next thing that we might do in this instance? All right.
Find the divisor.
Use the definition of divisibility. Define those divisors. Nice. So, by definition of divisibility, there's two things that we could say. Okay? Change.
Shouldn't you have before that stated that A cannot equal 0?
Yeah, let's go ahead. We'll put it down here. It doesn't matter when we put it as long as at some point we do. So thank you. Okay. But yeah, you're right. We should have definitely said that A is non-zero at some point. Thank you, sir. So what can we say then as a result of the definition of divisibility for this? Okay, so B equals XA, and then, Greg, you said C equals YA, correct, sir? Yes. Nice, very good. And then two other things, right? One of which is what Mr. Weber suggested, A cannot be equal to 0, and what's the other thing we should state? X and Y are integers. Nice job. So we're going to say X and Y are integers, and A is non-zero. So let me give you guys a moment to make sure that's okay. Okay, I don't think that's too difficult. I think most of you guys see that and you're like, oh, okay. I get that I have to make sure that it follows that conditional statement, and I get the idea of divisibility. Okay? Basically, guys, whatever's on the right side is equal to the left side times another variable.
I got a question. Why are you using X, Y? Is that the same number you use?
Oh yeah, you could use beta, theta, you could use zeta, whatever you'd like to, Don. I'm just using X, Y because that's what we used in the first example. Okay? All right, other questions, guys? Okay, so now we do the substitution step. Okay, so 2. So by substitution.
Wait, why can't A be 0 again?
Oh, because remember, if we're talking about divisibility, right? That means if you divide whatever's on the right by the left, you should get an integer. So let's say I had this statement, 0 divides 5, right? If I was to go through, that means that 5 over 0 should be an integer, but it's clearly not.
I was looking at it as 0 divided by 5.
Right. And that's what happens with a lot of students. They flip the definition.
Because that would have been fine.
Correct, right. Like for instance, if I said this, does 5 divide 0? Sure, that does, because 0 over 5 is 0. Okay, does that make sense now, Andre? Okay, that's all right. All right, by substitution, okay, what are we substituting into, guys? This one. Right. Again, the best thing to do, guys, is look at the right-hand side of whatever it is that we're trying to solve, or trying to prove. Okay, so by substitution, 10b minus 5c is going to be equal to what, please?
10xa minus 5ya.
10 times xa minus 5 times ya. Perfect. We just utilize the step, or the definition from the previous step. Okay, I don't think that's a big deal. I think everyone's good with that. Okay. What are we trying to show? We are trying to show that the right-hand side contains a factor of what? A. Okay. Well, I mean, it looks pretty obvious it has a factor of A. if we did what first? Factor the A out, right? Guys, isn't there a common factor of A in there? I don't think anyone doubts that. Let's factor this A out as a GCF, okay, just like we did on Monday, right? We did plenty of GCF stuff.
You can also do 5.
You could also do 5A, you're right. But remember, we're not trying to prove that it has a factor of 5, right? We're only trying to show it's a factor of A. Donnie, if you wanted to, you could do that, and then you would still verify that, okay? It just makes it a little bit easier to ignore everything else, okay? If I was to factor out the A, guys, what are we left out inside?
10x minus 5y.
10x minus 5y. And Don, notice that I didn't factor out the 5 just because now I've isolated a factor of A. Okay, and you're right, you certainly could do that. Okay. Do we know anything about 10x minus 5y? It's an integer, right? You want to call it m? Sure, why not? So by closure, we can say that this is going to be equal to A times m, where m is an integer. And check that out, guys. We have shown that 10b minus 5c is equal to am, which is the very definition of divisibility because it contains a factor of a. I'm so excited about it. Even though I've already done this for like 12 years, it's still exciting. All right. So, we're going to say, thus, 10b minus 5c is equal to am and contains a factor of A. I'll get there, guys, wait a second. It's obvious from above. Okay? Thus, A divides 10b minus 5c, okay, which is what we were trying to show by definition of divisibility. I know, too many eyes. Yeah. Don't worry about dotting them. I wish there was a shorthand way we could write divisibility. Okay. Any questions, guys? Okay. Routinely, whenever I give an examination for this stuff, I usually have a divisibility question on the examination. Okay. So I think now's a good time for you guys to get an opportunity to practice one of these. Okay. So, see if you guys can take about 6-7 minutes, be able to prove that last statement, okay? And we don't even need a C for this one, right guys? So, whoever wrote up this sheet may have inadvertently put a C in there. So if you can forgive that person and just scratch out that C, all right? And go ahead. See, I just reduced your work by 1/3. What's that?
Bad copy.
Yeah, he was a very, or he or she, I'm sorry. That person was a very bad copy and paster. Maybe that person had too many people coming out of his or her office at the time.
Either probably Friday.
Okay, that's perfectly fine. I just wanted to know when to pop in there. Okay, that's cool. No rush. And if you need something beforehand, let me know. Besides money.
Thank you.
You know,
Well, I could use that.
couldn't be all. Greg V. You have a nice day, sir. Kind of worried. Mr. Weber. Smith. So, give me a little trial across. James, can you pass that down to Andre for me, please? I know you could, will you? Maybe I should just say please do it. I just can't really do it. Hostage.
Oh, okay.
Sorry, I didn't see it. Mr. R, how may I help you, sir?
I got a question.
I might have an answer.
All right, let's see. Should I do like x to the power 5, then a to the power 4 times a?
Or because you're trying to show that a cubed, you mind if I borrow your pencil? Would this be okay?
Yes. Oh yeah.
Okay.
Yeah, got it. Got it.
Something that may or may not be helpful is that a to the 5th is equal to a cubed times a squared. That may or may not be helpful when you guys are doing your proof. Oh, Art, I'm sorry, bro. You should have thrown something at me.
Let's go.
Maybe like one of those 3,000 pens you have there.
It was good.
Does it look good? Let me see. That looks nice. Good. Perfect. That
Cool.
looks great.
Okay.
Nice job.
Thank you.
Okay. So Art, how many of those pens and pencils do you really use? In a
All
class
of them.
period? All of them?
Yeah, you know why I have them?
Your loves. in case you lose one?
No, well, I love women in general. So
Oh.
when I say beautiful girl, I give her a pen. Then I
Oh,
see a
okay.
hot sister coming, I give her the other pen. Then
Okay.
other friends come in, I give the other friend. Keep it, because
Do you do the same thing with roofies?
whatever I get, whatever I get my hands on.
Did you know that Bic pens, when they came out in the 50s, I think it was, something like that, they were sold for like 18 or 19 cents a pen.
Really?
They're still that price
Yeah.
today.
Well, I guess back then, though,
Inflation hasn't, right.
it hasn't affected the utensil market, I guess.
Useless fact, but still.
That's pretty neat though, because, I mean, you think like consumer price index affects everything.
And it does, and it did affect the pen. The problem is manufacturing brought down the cost of making the pen so much. Yeah.
Now these are just like the regular big pens, not the fancy ones that
Right.
make your
Not the
breakfast
ones,
for
no
you.
matter what you go in there, it's gonna cost you $12.
Yeah.
Frickin'
The
even
thing that has the
cheap
pillow
pen.
around it.
Oh,
Yeah.
you can spend over $100.
Ridiculous. Okay guys, let's go through this, and then if you guys have some questions about the assignment 4, I can answer those for you. Okay, so I started out by defining the x, the a and the b, okay? I said a was non-zero, and of course I had to say that a divides b. Okay, that's crucial to the proof. If we don't say that, we're not going anywhere with this. Okay? I used the definition of divisibility. I said that b was equal to a times x. Okay, and I also said that x was an integer. So, does that look good so far, everybody? That's not fun. Okay. Because we're trying to show that b to the 5th contains a factor of a cubed, what I did was I substituted into b to the 5th. So b to the 5th equals ax quantity to the 5th. Okay. Somebody tell me, what's the next thing that they did to be able to show this proof?
By multiplication?
Yeah, we just used the power of a product rule. We could just say by multiplication. Sure, multiplication's nice. And or what did that become?
A to the power 5th, x to the power 5th.
A5, x5. Okay. There may or may not have been a hint that could be helpful at this point. Okay. So what do we know about a to the 5th? A cubed times x, a squared. Good. So we're going to say that this is equal to a cubed times a squared x to the 5th, right guys? And that's just factoring, right guys? I mean, literally, when you pull apart numbers, okay, or variables like that, that's just factoring. Like remember, for those of you guys that suffered in Calc 2, you had to break off the sine or the cosine to be able to do the correct u substitution. This is exactly what we're doing. We're factoring off an a cubed, okay? Or maybe you don't remember that because it was a horrific memory and you repressed it. Sorry. So this is factoring. And then I think this might be it. Because don't we see that there's a factor of a cubed in there? What's the only other thing that we really need to do?
A cube m closure.
A squared x to the 5th is equal to what? M or
M.
something like that. Nice. So we can say this is a cubed m, where m is an integer. Okay? This whole thing right here is just multiplication. Okay? Literally, it's just 2a's and 5x's being multiplied, so it just becomes a new variable. We're going to call it n. Okay? That's closure. And we're done, right guys? There's not a lot of algebra going on here, okay? So, but again, it's a little bit sneaky because most of the time we're so used to multiplying things. We're not used to factoring off things, okay? And that's what we do in discrete math. We look for sneaky ways to factor things off, or the one trick where we might have to say like 7 is 6 plus 1. We just pull things out like that, okay? All right, so what we can say is that thus, b to the 5th is equal to a cubed m and contains a factor of a cubed. Therefore, thus, hence, whence, a cubed divides b to the 5th by the definition of divisibility. So, let me give you guys a few moments to look at that, digest it. Hopefully it doesn't come back up. but are there any questions I can answer for you guys about divisibility proofs? Okay. For most students, from my experience, the hardest thing for students to remember is where to substitute into. So remember, always substitute onto the right-hand side, okay, of what it is that you're trying to prove. The rest of it should be good. Okay, Fred, go ahead, sir.
So like, you don't even need to worry about the A cubed.
No, because that's what we're trying to show eventually. And if you do all your algebra correctly, you're going to see that it does contain that fact.
So the only thing you really need to look at is that far right.
That's exactly right. The rightmost thing in that line. Okay, that might be the most useful thing. Okay. Other questions before I give you guys maybe a hint or two about the assignment? Okay. So let me pull up assignment 4 really quickly because there was one question I wanted to make sure I gave you guys a hint on. And Greg asked me for this before class. Greg asked, not Greg did. Assignment 4. Yes, I want to open it. All right. Greg, correct me if I'm wrong. It was problem 3. Is that correct, sir?
That's it.
Okay. So. No, that's not right. Okay. So, can everybody see this? I'm trying to make it so everyone can see it. I'm not doing a good job here.
You can scroll and scroll up on the map.
Oh, here it is. No, I'm sorry, Don. I was listening to you, but there we go. Okay. So basically, this is the problem that I want to show you guys like a little bit of a hint on. Okay, it's similar to what we did in class, but there's a little bit more algebra involved. If m is any odd integer, then -1 to the n is equal to -1, which you guys already know. Okay. So I'm going to skip down to the point where you guys have defined all the variables. And you get to the substitution step. So you guys, like, you're going to do all the 1, okay? And you guys are going to do substitution. And you guys are going to eventually say that -1 to the m is equal to -1 to the, like, 2x plus 1, okay? And Greg, I'm assuming that's where you got to, and you're like, well, F this, I'm not going to use, like, any logarithms or anything like that.
That's
because,
right.
oh, yeah, and you probably were starting to beat your head up against the wall because you didn't want to do that, right? Okay. Let me give you guys a suggestion for this, okay? For those of you guys that have recently suffered through Calc 2, you guys might remember that you can factor off one of these -1s and rewrite this as -1 times -1 to the 2x. Okay? So that's -1 to the first. Does that make sense, Greg? Right.
Yeah, I actually thought about that too, but I didn't think you could keep it that way because
Oh,
the
no.
definition is 2x or 2n or whatever.
Right, yeah, you can definitely do that, okay? So you were thinking in the right way, okay? Guys, didn't we already show in class that this is equal to 1? Okay, so all you guys have to do is just look at the proof we did in class, show that this equals 1, and you're done, okay? So show that equals 1, use in class proof, okay? And then obviously close it out. So, Greg, does that help out a little bit? It's like, duh, now I got it. So, yeah. But sometimes you just need a little help in to be able to do this. Okay. Is there anything else on the assignment that might look like it's tricky? In fact, number 5 we did, didn't we, in class? So nobody better get that one wrong. Boy, that would be embarrassing. What's that?
I just think, yeah, I redid it, I didn't know.
Oh yeah, yeah, just do it. I mean, just do it again, guys. It never hurts to
We
get
did
some
number
free
1 in
points.
class too.
We did number 1 in class?
Yeah.
Jeez.
That's fine.
Do we do number 2, 3, 4, 5, 6, 7? That's fine. Okay. So, oh, let me show you guys number 7 real quick, because it's not that difficult, but I just want to show you guys like a hint on that one. It says the opposite reciprocal of a non-zero integer is rational. Okay. So for number 7, okay. So you guys are going to define, let's just say x is going to be some sort of rational number. So x is rational, which means x is equal to, what is it, a over b. Where we would have to say a and b are non-zero. And the reason we say a and b are non-zero is because it says that the opposite reciprocal of a non-zero integer. That means the numerator nor the denominator cannot be equal to 0. Okay, so does that make sense, guys? This is why both of them are in this one instance. Okay? So, now there's no substitution. Okay? So this is just the definition of opposite reciprocal is going to be equal to 1 over x, or -1 over x. And guys, what is negative 1 over x equal to with respect to a over b? Negative b over a, right? Nice. And then negative b over a, isn't that really the same thing as like c over a, since the opposite of b is just some other integer c? Okay? That's really like a closure step right there. Okay? So that's literally the entire proof, like the algebra for that proof. So I always get students that get really, really confused on this one, and it's literally only meant to be like a step or two. Okay? So when you guys go home, make sure you use this hint to be able to help you guys. And obviously you're going to write a little more formal than this. Okay? This is just like the bare bones stuff that you need. Okay? Was there anything else that you guys might look at and looks like it's going to be difficult for you guys to work through? I think those might be the only two that we don't have like an explicit example for. Okay? Well, I guess it would help if you could see the first 4, but then again, we already did the first 4 in class, so it doesn't matter. So, okay, so if you need some help with stuff, stick around so I can help you guys out with whatever you need. Okay, at least in the street math. If you guys are going to get here a few minutes early next time, I'll be happy to help you guys out there. Okay. All right, guys, have a good week, good weekend. Only 2/3 of the class left to go. Yay.